Welcome to GeekDIYMechanic. The purpose of this video is to discuss the basic concepts needed to understand automotive circuits. This video will not go into great technical depth on this topic. I suggest looking at this video as a primer for the concepts discussed. From my experience, we will introduce you to the necessary circuit concepts, allowing you to progress through the provided training material and allow you to start to understand and possibly work on automotive circuits. So let's get started. From the home page, let's navigate to Knowledge, Electronics Concepts. As a prerequisite, it is suggested that you have read and studied the following. Physics classroom. It discusses electronic concepts and terms much more in depth than I will. Big Bad Tech does a phenomenal job at explaining electronics. I suggest the Basic Electronics series. Again, please consider this video as a very high-level explanation to electronics and circuits. The video is intended to be supplemental to the reading material provided in the resource section of this website. Okay, now that enough disclaimers have been stated, let's begin. Let's click on what is a circuit. Circuit itself has late origins from Middle English, which is, one could say, to go around. So I like to look at a circuit as like a racetrack. A racetrack usually uses the starting line as the finish line. I look at a circuit the same way. Electrons flow from a power source, example like a battery, power supply, or alternator, start out on the track, the wire, travel around and return to the power source. Since you can't actually see electrons when working on a circuit, you have to visualize what's going on. You can see the results of the electrons flowing though. What is convenient is that electrons follow a very specific, precise rule set. To successfully work on a circuit, you need to develop a mental image of a circuit by using the following tools. Basic electronic concepts, understanding how components, sensors, and actuators behave, being able to read circuit diagrams, and my favorite is to use the Java Applet Circuit Simulator, which I will show you in just a moment. A digital voltmeter, a scope meter, or an oscilloscope. Let's discuss some common units we will commonly use while analyzing automotive circuits. Let's click on units of measure. We will discuss the top 3 units of measure you will encounter: volts, amps, and resistance. Volts are probably the best known unit of measure that we deal with. This is because we all use batteries in our daily electronic devices, example remote control, cell phone, automobile. These batteries come in different capacities: 1.5 volt, 6 volt, 9 volt, 12 volt, and on. But what does volt really mean? In its simplest definition, it is a measure of potential difference between 2 points in a circuit. To illustrate this concept, I chose a roller coaster simile for a variety of reasons. One reason is that you enter and exit the roller coaster in the same place. You know, those long lines. The other reason is because a roller coaster ride is comprised of ups and downs. Each up and down can be measured from its topmost point to its lowest most point. This is like voltage. It represents the potential difference between any 2 points. Notice, it doesn't necessarily represent the maximum height of the hill or fall. That would only occur if the bottommost point is close to the ground. Again, this is a very simple mental picture to allow you to get started in electronics. I'm sure as you get more into it, you'll obtain a more accurate definition and meaning. But this simple mental picture will allow you to start your journey in automotive circuit or electronics. Let's move on to the next electronics unit of measure, the ampere, usually referred to as amp. Again, I use the roller coaster analogy to describe amps. It is how many riders go through the ride at a time. Notice you have the same potential difference. But have differing amps. If you notice, there's one car here and there's 2 cars here, allowing 4 riders through versus 2. So that means more people can go through the ride at once, meaning the ride is able to perform more work, the one on the right, because more riders can go through it per cycle. Here are some examples of how many amps a component on your car uses. Both headlights on your car probably need about 20 amps to illuminate, whereas a car starter needs 150 amps or more to turn over the motor. This shows the more work needing to be accomplished, the more amps are needed. Turning over a motor, if you've ever done it by hand, is quite a chore. The last electronic unit we will cover in this section is named resistance. Resistance is the opposition to electron flow. I liken it to a kink in a hose. The looser the kink, the less flow restriction is hindering water flow. The tighter the kink, like on the right here, the more restriction impeding water flow. Obviously, the kink in the hose is similar to a resistor or a load in electronics, like a motor, sensor, or whatever. A load can be a coil, motor, headlight, actuator, sensor, just to name a few. The unit name representing how much resistance a component has is ohm. Great. Now we have briefly discussed volts, amps, and resistance. Let us use the Java Applet simulator to see these concepts in action. Click on Circuit Appearance. Before we start interacting with the simulator, let's discuss what is being displayed. Please notice that the circuit representation starts and ends at the battery. Battery is right here, goes all the way around like a racetrack, goes through the switch, goes through a load, goes to another switch, goes through the wire, and goes right back to the battery. Notice the 100 ohm resistor, which can be an actual resistor, a bulb, a motor, a relay, a solenoid, an actuator, or whatever. That's right here, the 100 ohm resistor or load. That's considered the load in the circuit. Notice that all the voltage was used up by the load by looking after the load and noticing 0 volts. So 12 volts are here, travels along, the load consumes it all, and 0 volts are going back to the battery. All the voltage is used up. Notice there are 2 switches as well. These switches are used to stop electron flow, which stops current. These are a switch right here. Whoops. Notice the simulator indicates when electron flow is occurring and not occurring. Obviously it's not occurring now. Now it is occurring. Let's see how changing the resistance impacts this circuit. With the load at 100 ohms, notice that the voltage is 12 volts and the circuit amperage is 120 milliamps. Displayed right here, 120 and 12 volts. Let's change the resistance to, let's say, 1,000 ohms and see what happens. So I double click it, change it to 1,000, hit OK. Wow, those dots really slowed down. But why? After changing the load resistance to 1,000 ohms, representing a bigger kink in the circuit, like in the hose analogy, what do we observe? Incoming voltage didn't change. Notice it's still 12 volts. The potential difference between that point and that point is still 12, because that's what the battery is generating, or producing, or supplying, however you want to say it. But the current went down to 12 milliamps. So that kink is really slowing down the electron flow. So I'm going to move it back to 100 just to make it a fast moving circuit. The next important topic to discuss is how an automotive circuits are usually turned on and off. Let's click on the switch to see what's going on here. So I'm going to click on switch circuits. Sorry about that. Going to switch circuits. There are primarily two techniques that automotive circuits are turned on and off. The difference is where the switch is located in regards to the load. This is load. Before load or after the load. Remember, load can be a motor, actuator, relay. To discuss this concept, the diagram was modified to have at least two test points placed before and after the load. This will allow us to monitor the voltage at each test point in real time at the bottom of the diagram. Here's what so you see test point 1, this is the value of test point 1. It's at 12 volts. Test point 2 is right here, and this is displaying it. It's at 0. Remember, the load is consuming all the voltage across it, so this should be 0, this should be 12. Let's start by opening the top switch. After opening the switch, we notice that both test points drop to 0 volts. So when the top switch is closed, allowing current to flow again, it pulls up the voltage from 0 to 12. Thus, switches in this position of the circuit in relation to load are considered pull-up or power side switches. So let's see that again. So right now it's at 12 and 0. Open it. They both drop to 0. See that right here? And we're looking at these test points, because that's usually where you back probe in at a sensor. And then when you close it, it pulls up this value. Remember, it was at 0 and now it pulled it up to 12. This still stayed 0 because it's on the other side of the load. The next switch will teach another important concept that you will constantly draw upon when working on automotive circuits. Here it is. Voltage drop only occurs across a load when current is flowing. Again, so important. Voltage drop only occurs across the load when current is flowing. Let's see this in action by closing the pull-up switch. It is closed. and opening the pull down, this bottom switch. Wow, what do we notice? Both test points on both sides of the load are at 12 volts. Remember before, down here was 0. I open this and the voltage goes through the load because there's no current flow. So it's 12 and 12. This is a very important concept. That's why I'm emphasizing it. You'll use this trick all the time. Again, voltage drop only occurs when current flows. So, when the pull down switch, that's this one down here, is opened, the current flow is stopped and the voltage drop across the load does not occur. Thus, 12 volt appears on both sides of the load. Both test points are reading 12 volts. Let's discuss why the bottom switch is called a pull down switch. When the switch is open, test point 2 is at 12 volts. Test point 2 is at 12 volts. But when the switch is closed, allowing current flow, the voltage will drop to 0, causing a voltage drop across the load. Therefore, switches on this side of the load are called pull down or ground side switches. This is at 12 volts. Once I close it, it pulls it down. It was at 12, it pulls it down to 0 volts, to ground. The last important circuit concept that this video will discuss are two circuit configurations. Let's click on circuit types. This demonstrates two circuit types, series and parallel. At a high level, both circuits have the same power source, 5 volts, and both circuits have the same starting current, 25 milliamps, 25 milliamps. Let's examine the series circuit. That's the circuit on top. First, notice that the current is constant at all points in the circuit. 25 milliamps, 25 milliamps, 25 milliamps. But also notice that the voltage differs in the circuit. 5 volts, there's a load right here, goes to 2.5 volts. Another load takes it to 0. Notice, all the voltage must be consumed when it comes back to the battery. This is an important concept. This will help you understand voltage drop tests in the future. We're not going to cover that now, but keep that in your hip pocket. That's a upcoming video. Again, the load in the circuit will consume all the voltage, and that's what's happening here. 5 goes across this first one, goes to 2.5, against the next one, goes to 0. All the voltage is consumed by the load. The last thing to notice is if at any point in the circuit is disrupted, cut, broken, complete circuit flow is stopped. So if I break it here, no current flow. If I break it here, no current flow. If I break it here, no current flow. So no matter where I break the line, it disrupts current flow 100%. Important to know. Sort of like those old Christmas lights. Remember we used to buy cheap ones? One light went out, the whole thing went out. That's because they were done in series. One after the other. One goes out, they're all out. Let's move on to the parallel circuit to see how these two circuits are similar and differ. That's the bottom one here. Examining the parallel circuit, we notice that the voltage is the same on both branches of the circuit. 5 volt, 5 volt, supply is 5 volt. But the current on both these branches have to be shared and is therefore split between the two due to the fact that the load in each branch is the same. Because these are both 400 ohm, the current is split from 25 milliamps to 12.5 milliamps per branch, but the voltage is the same. Obviously, if a break in the circuit occurs before the branches, that will cause the current to stop flowing in the complete circuit. So if I take that out, the circuit is completely down. But if one of the branches are broken, the other branch will continue to flow current. Let's illustrate that. There you go. So this branch is not working anymore. No current is flowing, but this branch still is. It is still getting voltage and doing its job. So this is sort of modern Christmas lights. A light goes out and many of the lights will still continue, if not all of them. It depends how they wire it. So in summary, the characteristics of a series circuit are: current is constant throughout the circuit. Voltage is dropped across all loads. Current flow is disrupted if there is any break in the circuit, anywhere along its path. The characteristics of a parallel circuit are: voltage is constant across all branches, 5 volt, 5 volt. Current is divided among the individual branches depending on the load of that branch. What I'm trying to say is, if this was 500 ohms, the current would be changed up. There'd be less current on this branch and more current on the other. Current flow can continue if a break in the circuit is located in any of the branches. So if any of the branches drop out, the other branches still continue to function. I invite you to visit these pages and play with the circuits. I suggest experimenting on these circuits to hone these concepts in your mind. This short video briefly described concepts that are important to work on automotive circuits. Please consider this as a primer. I hope you use the resource section of this website to obtain a deeper understanding of automotive electronic concepts. Thank you for watching. I hope you found the information helpful.